Thanks for joining me for another math problem of the week. So for today, we are going to consider f that is a polynomial of degree 5 such that this holds. And we are asked to find the value of f7. So far, I received more than 100 responses. More than half of them claim that this is Fibonacci sequence that we can see from 1, 2, 3, 5, 8. So it's clear to them what is the next answer. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
Based on the sixth number here, can we say that this forms Fibonacci sequence? Obviously, it is not necessary, especially it said that it is a polynomial of degree 5. So the next number may or may not equal to 13. On the other hand, people worry that there's insufficient data to determine what is the next value. A polynomial of degree 5 is actually means fx can be written at ax5 plus bx4 plus cx3 plus dx2 plus ex and plus f. And note that a cannot be equal to 0. So this is a general form for a polynomial of degree 5. So there are 6 unknown that to be determined. And we have 6 pieces of information. Using these 6 pieces of information, we can form 6 equations as shown. So what we need to do is we have to solve the system of linear equations. Transfer it into matrix. So we can make use of technology, get the inverse matrix, and get the answer. Another way of solving this problem is by remainder theorem. Example, from these two, I will say that fx will equal to x minus 1, x minus 2, plus 1. With the quotient here, qx. Note that qx itself is also a polynomial of degree 3. Just transfer this fx into this form, it is already easier for us to solve the system of linear equation because we need only another 4 information, that is from here. Another method to solve this question is by Lagrange interpolation. In this video, I will focus on a specific method to solve this particular question. That is, I define d phi x equals to fx and dnx equals to dn plus 1 x plus 1 minus dnx. Using this definition, d4x will be equal to d phi x plus 1 minus d phi x. And note that dnx is also a polynomial, and this polynomial will be of degree n. So we can get from here d4 1 will be equal to d phi 2 minus d phi 1. And this actually equals to f2 minus f1, that is equals to 0. d4 2 will be equal to d phi 3 minus d phi 2, that is 1. And d phi 3 that you can see from here also equals to 1. D44 will be equals to 2, and D45 is equals to 3. Okay, and we can continue for D3x. Based on this, we can actually build a table. Using this table, we are ready to get the answer very easily. The entry in this is actually means that the value of D51. So this is D51. D51 is equals to 1. D52 is equals to 1 from here. D53 equals to 2, 3, 5, 8. And we are going to ask what is this value. Using this definition, D41 will be equals to D52 minus D51. That is 1 minus 1. You have a 0. From here, this is 2 minus 1. This is 3 minus 2. This is 5 minus 3, and so on and so forth. And this will be 1, 0, 1, 1. This is negative 1, 1, 0. 2. This is negative 1. And this is negative 3. We will also see that d n x is a polynomial of degree n. This is a constant function. As this is a constant function, it is always equal to negative 3. And now we do backward. In order to have it negative 3, I need this to be a negative 4. Negative 4 minus negative 1 will give me negative 3. In order to have a negative 4, this should be negative 4. This should be negative 3. This should be 0. And in order to get 0, this should be 8. And use this simple idea, 7 will be equals to 8. So that's the end of my presentation. Hope you enjoyed it. I'll see you next Tuesday.